Okay, class. Last time we was doing question number 12. And question number 12, you check. Question number 12, you take the derivative both sides. The goal is to find dy over dx. So you take the derivative both sides with respect of x. So you end up having this one. Okay? You end up having this one. So now if I call here 1, here 2, okay? And now if I set this one be 0, the first one, sequence xy can be 0, or this one can be 0. Now let's put the case 1. The case 1 is the sequence of xy. If the sequence of xy is non-zero, of course it's non-zero. This one is impossible because this one have to be equal to 0. Because either one, okay, this one or this one. If this one is non-zero, then this one have to be equal to 0. And then we don't have no information about this one, okay? Now, let's do case 2. Case 2 is when you have the 2 side is equal to 0, okay? Case 2, this one is equal to 0. Case 2 is when 10 of xy, and you have a plus sequence of xy is equal to 0, okay? And now you get, 10 is sine over cos. You have sine xy divided by cos xy plus sequence of xy. You have 0, and is sine of xy over cosine xy plus 1 over cos xy, and this one equals 0. So here you can have a sine of xy plus 1 over cos xy is equal to 0. So this one is only true if and only if sequence of sine of xy equal to negative 1. What makes sine of xy equal to negative 1 is when you have, for example, just a sine is when you have a kind of sine is sine of 2k plus 1, for example. Let's check it here. Let's check here 2 pi over 2. So this one you will have a pi, you will have a sine. I know it's 4k plus 3 over pi over 4. You may be confused how I get this one. Just why? Because this one is true if and only if you have xy has to be equal to 4k plus 3 pi over 2. You can find that one by just using the unit circle and try to check where it should be. Should be on sine, and you have 4k plus 3. Okay, the other way to find the 4k plus 3 pi over 3 is this. Sine of xy equal to negative 1. So for example, you can have sine of this one is, if it's 1, you have this one, 2k plus 1 pi over 2. Now, just let me give you an example here. If this one is a case, you have this one. So you will have a sine of, if you put the pi over 2 inside, you have k pi plus pi over 2. Okay? And here you can tell is sine here, and cos you only can have negative 1 to the k. Okay? Now, we have here, what you have here, this one have to be negative 1, then k have to be, since it's negative 1, then k have to be even number. No, have to be odd number. So you can have 2n plus 1. If you take the 2n plus 1 and replace it back here, you can have xy is equal to 2 parentheses 2n plus 1 and put the bracket, you have pi over 2. And here you have 4n plus 2 plus 1 parentheses pi over 2. And here you can have 4n plus 3 pi over 2. The way I prove the way I get this one here. Okay, you can do it directly by using the graph. Okay, by using the unit circle, you can do it directly from here. But if you can't, I advise you to use that way. Okay, and that way will be easy because from here you can only found negative 1 if k is odd. If k is odd, you can tell. You can have a 2n minus 1. You can have a minus 1 to the 2n, which is 1, and you have a negative left to the 1 is negative 1. That's why you have a negative 1 here, and then you end up having this one. Got it? Okay. Just want to make sure you understand the process. The next is this one. Okay, now you get this one. It's for all k, and k is integers. And now you have this one will always hold, by the way. This will always, this case, let me write down the case. This case always hold. Okay, this case will always hold. Now, from here, how can we decide dy over dx? Again, our goal is to find the dy over dx. How can we decide from here? We do not have enough information. Okay, we do not have enough information for dy over dx. That's it. That's all you have to say. Okay, we do not have enough information. That's why we can't decide. We do not have enough information, and that's why we cannot. That's why we cannot. We can't not decide dy over dx. Now, for all x and y in R, if you have x and y is different to 4k plus where is this one? 4k plus, okay, it's 4k plus 3 pi over 2. Okay, let me write down the bottom so you can see one. For all x and y integers, no, for x and y real numbers, and if you have a 4k plus 3, x and y is different to 4k plus 3 pi over 2 is different, then 4 from this one, I call it 1. From here, I call it 1. From here, I call it 1. From here, I call it 1. 1 will become 1 have to be equal to 0 if this one is different to 4k plus 3 pi over 2. Then this one, then 1 equal to 0, and 1 is y plus x dy over dx equal to 0. And then for we can conclude dy over dx is equal to negative y over x. That's all. This is true. That case is true if and only if x and y is different to 4k plus 3 pi over 2. Just make sure. Okay. Now, for this one, let's move on for this one. For the next one, we have same thing. The process is to find the dy over dt. So if we take the partial derivative both sides, so we can have a d over dx of this one, n square root of x squared plus y squared, and then plus x plus y equal to 4. Okay, so now take the derivative both sides. So you can have with respect of x, here you can have with respect of x, you can have 2x divided by 2, and you can have the square root of this one. Okay, you have the square root of this one, x squared. Oh, hold on, let me just change here. I think it will make more sense if I change it. So if I can change here, let me change it here. Here I can rewrite it as 1 over 2 ln x squared plus y squared, and you have plus x plus y is equal to 4. If I take the derivative both sides with respect of x, of this one is 1/2 ln x squared plus y squared, and you have plus x plus y is equal to 4. And if you take the derivative both sides with respect of x, you have 2x divided by 2x squared plus y squared, plus now with respect of here you have dy, then you will have 2y over 2 parenthesis x squared plus y squared, and here you will have dy over dx. And here you can have, with respect of x, you can have only 1, plus here dy over dx. Okay, and you can set equal as 0. Why? Because the derivative of 4 is just 0. That's why you have here 0. Now we can combine, we can factorize here. We can just combine the dy over dx above. So let's see what we get. You can have 1 plus this one, 2y over 2x squared plus y squared, parentheses, you have dy over dx, and here you can have this one. You can just add them first. You can have plus 1 plus x over x squared plus y squared is equal to 0. Okay, so now here also the 2 can cancel out, and you can have x squared plus y squared plus y, parenthesis, dy over dx, and divided by, you can divide it by x squared plus y squared, and here you can have plus x squared plus y squared plus x, and you can divide it by x squared plus y squared, and that's it. And you can set it equal as 0, and this one will become x squared plus y squared plus y, parenthesis, dy over dx, and here you can have x squared plus x plus y squared, and you can have equal as 0. Okay, and now you can put it in cases. And now you can put it in cases. Let's call case 1. Case 1 is when you have, let's put this one is equal to 0. Case 1, if y plus x. Let me call it y plus. Case 1 is when this one, x square plus y square plus y is equal to 0. Okay. In this case hold true if this one you set it equal to this one. This one equal to if x square is equal to y, negative y square minus y. And this one is hold true also if you have x is positive negative, so square root of negative y square minus y. Okay. So the domain for this one is if the inside is positive or negative. Okay, it's positive or equal to 0. You have negative y square minus y is greater or equal to 0. And then here you can have negative y parenthesis y minus 1. Y plus 1. Y plus 1 is greater or equal to 0. And you can tell you have y equal to 0 and y equal to negative 1. Okay. And for all value for this one to be hold, y have to be between negative 1 and 0. Any number you pick here, this one will be true. Okay? Any number you pick here, negative y square minus y is always positive or equal to 0. Any number. If y equal to 0, this one equal to 0. If y equal to negative 1, you can tell this one equal to 0. Other than that, anything you pick here, it will be true. Okay? Now, if y equal to negative 1, you have a negative 1. If y equal to negative 1 is a positive 1, and you have a 0. Now, let's go. In that case, so if this one is 0, so we will have a 0 times dy because of this one. If this one is 0, so we can have a 0 times dy over dx is equal to negative x minus x squared minus y squared. Okay. Now let's put it in cases. In case we have this one equal to 0 and this one is non-zero. Okay. If let's put it in other cases. Let's call it I. Okay. If this one negative I and minus x squared minus y squared is equal to 0, so what do we get? We can get this. Let's try to find this one, and this one you can tell is okay. This one is just if you multiply both sides by negative 1. If you multiply both sides by negative 1, what do you get? You will get x squared plus x, and you get plus y squared equals 0. So here you know x plus 1/2 squared is x squared plus x plus 1/4. And you know this one will become x squared plus x is equal to x plus 1/2 square minus 1/4. Okay, take this one, replace it here. You will get x square plus x plus y square is equal to, look at this. You take this, you take this and I replace it here. From here, I get this one. Okay, from here I get this one. Replace it by x plus 1/2 square minus 1/4. So you will get x plus 1/2 square minus 1/4 plus y square is equal to, remember this one is equal to 0. So now I get x plus 1/2 square plus y square is equal to 1/2 square. Okay. This one we have a circle. We have a circle center at -1/2 and 0 with the radius. The radius of r is equal to 1/2. Okay, and now we get this one. So the second one, the second one is when this one equals 0. The second one is when this one equals 0. The second one is when x squared plus y squared, this one, when this one equals 0 here. So you will get x squared plus y squared plus y is equal to 0. Okay. So this one you will get y plus 1/2 squared is y squared plus y plus 1/4. Okay, and here you will get y squared plus y is equal to y plus 1/2 squared minus 1/4. So take this one, replace it here, you will get x squared plus y squared plus y is equal to x squared plus y plus 1/2 squared minus 1/4. Okay? And this one is equal to 0. So now you will have x squared plus y plus 1/2 squared is equal to 1/4. And 1/4 is 1/2 everything squared. So here also you get a circle center at point 0 and